In this video, we will give an example of circuit analysis. For the circuit shown, we would like to calculate the value of I1, which is the current flowing through the 5 ohm resistor. The circuit contains a 5 volt independent voltage source, 3 resistors, and a control source, which is shown with the diamond symbol. The control source is a current controlled voltage source, or a CCVS. The circuit contains 4 nodes, A, B, C, and D, and we will select node D to be the reference node or the ground node, which means that the voltage at node D is going to be 0 volts, and we will measure all other voltages with respect to this ground node D. To analyze this circuit, we will use all the laws that we have learned so far, which are Ohm's law and KVL and KCL. Looking at the circuit, we notice that the 5 volt source is connected between nodes A and D, such that the voltage VAD will be equal to the value of the source, which is 5 volts. Since D is the reference node, we will often write the voltage VAD simply as VA, with the understanding that it is measured with respect to node D. The current controlled voltage source is connected between nodes C and D, such that the voltage VC is equal to 3I1. The current I1 is the current flowing through the 5 ohm resistor, and using the passive sign convention and Ohm's law, we will get that I1 is equal to VA minus VB over 5 ohms. We can substitute this value in the previous equation so that VC is equal to 3 over 5 VA minus VB. We can also substitute for VA in this equation so that we get, so far we have written 3 equations as labeled, and we have substituted equations 1 and 3 into equation 2, and we have 2 unknowns in equation 2. One is VC and the other one is VB. Since both VB and VC are unknown, we will try to write another equation that relates these two voltages. For example, we will try to write a KCL at node B. The current I1 is entering node B. We do not have directions of the current flowing through the two 10 ohm resistors, and we are free to choose them to be in any direction, and we will make the selection as shown. Writing KCL at node B will give us that the currents leaving, which are I2 plus I3, minus the current entering node B, which is I1, will be equal to 0. The current I2 will be equal to VB divided by 10 ohms. The current I3 will be equal to VB minus VC divided by 10 ohms, and the current I1 will be equal to, as computed before, 5 minus VB over 5 ohms. This gives us another equation that relates VB and VC, and along with equation 2, we should be able to solve both of these equations for both VB and VC. We will substitute equation 2 into equation 4, and we will get this will give us one equation in one unknown, which is VB, and it can be solved for the value of VB, 65 over 23 volts. Once we know the value of VB, we can calculate other quantities such as VC, 30 over 23 volts, and I1, which is equal to 5 minus VB over 5, which will be equal to 10 over 23 amperes. And we have calculated what we needed from this circuit. We can calculate any other value, for example the power supplied by the 5 volt source or the power dissipated in any of the resistors if needed. To summarize, to analyze any circuit, we will use all the 3 circuit laws that we have learned so far, which are Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law.